This video is going to cover something called Huffman Coding. This is a really powerful algorithm used in data compression. There are some downsides of it, that it's not as popular as some other compression algorithms, but it's a really will compress files down quite a bit if you use it. And so the idea is we're going to have some sort of a data file or message, and it's going to have symbols. Now for this one, to keep life easy, I made it so there's only 4 symbols, A, B, C, and D. And what we're going to do is we're going to figure out how can we encode those 4 symbols using zeros and ones in order to get the shortest possible length of the message. And before I get into it, I want to tell you a really quick story about this algorithm. At least a story that was told to me. I'm not completely sure how truthful it is. But the guy Huffman was a student at MIT, and his teacher gave them an option of either doing a final project, a little paper, or having to take a final exam in the class. And Huffman decided that, David decided that writing up a paper would be less work for him than studying for the final. So he did that and came up with this method, and it turned out that it's actually the best possible method you could ever come up with. So it's kind of a funny little circumstance for that. Now, let's suppose, I'll call this the naive approach. And it says that we have 4 symbols, A, B, C, and D. So what if I just made A 0, 0, B 0, 1, C 1, 0, D 1, 1. Then my average length here would be 2 bits per symbol. And so this would give you a file that is just very mediocre in length. It wouldn't really compress it very much, if at all. However, it turns out that we can do better. We can make the average length smaller than 2, which seems crazy because if there's 4 things, we can't describe 4 different things using fewer than 2 bits, but it's going to still have the average being smaller. And so this is going to be a really nice application of trees that we've been talking about. Trees is a type of graph. And what you do is you're going to go ahead and draw your 4 symbols, and you're going to put their frequencies next to them. And you need to put them in decreasing order here. Then what you're going to do is you're going to combine the 2 smallest ones. You're going to add up the frequencies, and then you're going to assign either 0 or 1 to each one of them. It's best just to be consistent. If you're going to put 0 on top here, just put 0 on top for all of them. And what you're then going to do is you're now going to just repeat that process. So now I have 3 frequencies, 0, 0.5, 0.25, 0.25. I combine the smaller 2 of them, and they're now going to have a total frequency of 0.5. I put my zeros and ones here. And then I now have only 2 frequencies to do, 0.5 and 0.5. I combine those together to get 1.0. Once you get to that, you're done. Assign my zeros and ones. And then if you want to figure out what your individual code words are going to be, you're going to just trace your way backwards through here. And so what that would mean is my A is going to have just the symbol 0. My B is going to be the symbol 1, 0. My C is going to be 1, 1, 0. And my D is going to be 1, 1, 1. And if I write my frequencies here, 0.5, 0.25, 0.15, and 0.1, then now my average length would be probability 0.5 times length of 1, plus probability 0.25 times length of 2, plus probability 0.15 length of 3, plus probability 0.1 length of 3. And what I get here is an average length of 1.75 bits per symbol. And so if you compare, the other one was 2 down to 1.75, that's about a 12.5% decrease. So going from here to here, that's a 12.5% decrease in the length of the message. Now again, there are some downsides to this method. There are some details I'm omitting because this is not a class about data compression. But if you were to take one of those, you can learn more about that. However, I really just want to point out that this is a nice, quick method. We're using a binary tree right here. Right, this is a binary tree. If you wanted to have not bits, but say a ternary system, you would combine 3 at a time instead of just 2. But computers are based on binary, so we don't need that. And this is a really, really powerful method to get a coding system here. So it was a quick overview. Should be able to handle doing an example like this in the future. But if you're interested in this, you can really research a lot more and get a lot more of the details on it.